Hello everyone, this is Carrie with Everwood Creations. Today we are going to talk about the basics of Toolpaths and your CNC, and do a brief overview of the options in the Toolpaths panel. I am using Vectric VCarve Pro version 9.5, so remember that things may be different for you if you are using a newer or older version of the software. Also a quick reminder that I am not affiliated with Vectric in any way, nor am I an expert by any means. We're all learning about this software together. If you know a better way to do something, feel free to comment down below. So let's get started talking about toolpaths. You may be wondering, what exactly is a toolpath? In machining, a toolpath is the path through space that the tip of a cutting tool follows on its way to producing the desired geometry of the workpiece. Toolpaths are perhaps the most important function of this Vectric software, as they are what tells your CNC what and where to cut based on your design. A toolpath is created at the end of the design process and contains the code which will give your CNC machine a set of instructions based on the vectors you select. A single project can contain anywhere from 1 to hundreds of toolpaths depending on the design. In the software, there are several types of toolpaths and different functions available to you in the Toolpaths tab, typically located over here on the right. If you don't see it on your screen, you can always click the Toolpath menu located at the top and select Show Toolpaths tab. The tab can sometimes be minimized over here on the right too. Clicking the tab opens it up. The first area we see is the Material Setup section. I cannot express how vitally important it is to make sure your information here is correct. One wrong value here and you could end up with project-ruining results. We can see from the illustrations that I have the material set to 3/4 of an inch with a clearance of 0.2 inches. I am zeroed to the top of the material and the home position is in the center. If any of this information doesn't match your project, you can hit the Set button and it will take you to the Material Setup tab where you can adjust any of these settings. Under the Toolpath Operations headings, there are two sections of controls. The top half is made of 12 types of toolpath creation tools, 13 if you have the laser module, which I currently do not. The bottom half are editing, previewing, and estimation tools involving the toolpaths. This lower portion has a list of the toolpaths currently in the project. First, I want to give you a brief overview of each type of toolpath. It will be just a glimpse, as I plan to do a separate video for each type of toolpath in the future. Among the basic toolpaths, we have profile, pocketing, drilling, engraving, and inlay toolpaths. A profile toolpath cuts around or along a selected vector. It is generally used to cut out shapes or create lines the width of the cutting tool. A pocket toolpath clears an area within the selected vector while not going all the way through the material. It can be used to make nice smooth surfaces and create different levels in your design. The drilling toolpath allows you to create drill holes at very precise locations and depths in your piece. This is often used for placement or when drill holes of a precise depth are needed, like in the back of a workpiece. The quick engraving toolpath is meant to be used with engraving heads, like diamond head tips meant to engrave on metal. It has both outline and fill options, though no preview is available for this type of toolpath that I can see. I've never actually used this one, though I hope to explore engraving in the future. Finally, the inlay toolpath gives you an easy way to create both male and female toolpaths for an inlay using the same vector, ensuring that they will match up perfectly. The software takes into account the radius limitations of the bit you are using and automatically adjusts for it. To see the inlay in action, check out our walnut box with inlay and molded sides video. Next, we have the 2.5 dimension toolpath options, including v-carve, fluting, texture, prism, and molding toolpaths. 2.5 dimension in the machining world is a simplified 3-dimensional XYZ surface representation that contains at most one depth, or z value, for every point in the XY plane, ultimately, it means it looks three-dimensional, but it actually isn't. The v-carve path is one of the most used types of toolpaths for a woodworking workshop, and is obviously how the very software we're using got its name. This toolpath uses a pointed cutter to carve into the material to a certain depth, leaving nicely slanted edges on both sides. Usually preferred for lettering or detailed shapes, you can also use v-carve toolpaths for beveling, like in our previous video. V-carving is incredibly versatile and is most often used for simple sign making and design carving. The fluting toolpath is similar to the profile toolpath in that you trace a vector. The difference is that you can change the Z height for the different areas of the path, allowing a more dimensional cut. The tapering effect can be used for decorative elements or to allow drainage on projects like cutting boards. The texture toolpath allows you to create a texture on the surface within a selected vector. It has a complicated algorithm it uses to randomize the output, creating some truly unique textures. Using this feature can create interest in plain areas of your project and really add to your finished design. The prism toolpath allows a V-bit to create angled lines that give the impression of standing out of the material, simulating hand carving. Clearing the surrounding area will give you dynamic shapes that stand proud of the surrounding areas. The Moulding Toolpaths allow you to sweep a profile across a given vector, creating a truly three-dimensional project. This can be used to create beautiful trim or frame moldings, though it does take a considerable amount of time. Check out our 2-video series where we used this tool to create molding, and then used the molding as the sides of a keepsake box. Finally, we have the 2 actual 3D toolpath options. The 3D rough toolpath allows you to use a larger tool to clear big areas from a 3D carve, reducing both time and wear on tools for the 3D carving process. This path clears the way for the more detailed work of the regular 3D toolpath. The regular 3D toolpath does all the calculating to give you a beautiful carving based on a 3D model in your workspace. While you can do a lot with the 3D carving toolpath in Vectric VCarve, it is important to note that it has limitations. A separate software called Aspire is needed for true freedom in the 3D carving process. But VCarve does a great job of allowing you to carve a 3D model that has been imported with minimal editing capabilities. Now we come to the other operations in the Toolpath tab that often go overlooked. This row of buttons is used for editing your toolpaths. You can access your tool database with this button, a function also available in the specific toolpath editing panels. This database is where you can keep information for all of your machining bits. They provide a nice sampling of commonly used tools in both imperial and metric, and give you the ability to add any additional tools that you may need. There are importing and exporting options as well as groups to keep them nicely sorted. Editing the toolpath simply opens up the toolpath panel of the path you currently have selected. You can also just double-click on the name of the toolpath down here. You can duplicate the selected toolpath, as well as delete it using these buttons. Here you can recalculate all of your toolpaths. If you make a global change to your piece, like material depth, or if you change vectors after calculating your toolpaths, you can use this button to recalculate all of your paths at once. The first 3 buttons in this row allow you to create and work with templates. If you have a standard way you frequently carve, this can save you time in creating toolpaths to those specifications. The first option is to load a previously saved template. Next, you can save a single toolpath as a template, or this button will allow you to save multiple toolpaths as a single template. When you load in a template, you need to specify a vector for each toolpath. The Create Merge Toolpath option allows you to merge toolpaths that use the same tool into one larger toolpath. This allows the software to more efficiently create the pathing for the tool. To merge toolpaths, you want to make sure that the paths you want to merge are visible. You can see this by looking at the panel down here. Any path with a check in the box next to it is currently visible. You can also tell a toolpath is visible because it will show up as lines showing the path of the tool in both the 2D and the 3D view. Once you have all the toolpaths you want to combine visible, you hit the Merge Toolpath button and it will open this panel. First, we see a list of the toolpaths to be merged, with the tool for each path listed underneath. If you have selected a path that uses a different tool, you'll get an error message like this, explaining that you must use the same tool for merged toolpaths. Next, you have the ordering section, which allows you to choose the movement of the tool in the new merged toolpath. You can choose left to right, bottom to top, grid, or shortest path. As it states here, if more than one option is chosen, it will automatically choose the fastest. When checked, the Merge by Part option tries to group related vectors together, meaning it will cut the part individually before moving on to the next. I'll give you an example. See how it cuts each individual dice completely before moving on to the next one. If you uncheck this box, you will get a warning message saying that it will not preserve any ordering within the toolpaths. When I calculate these same toolpaths, you see how it moves the tool differently independent of the individual parts. Finally, you can give your merged toolpath a name and then create the toolpath. Note that the original toolpaths are still there. You will want to make sure that you are mindful of that when exporting your toolpath to avoid duplicate carving instructions. The Array toolpath allows you to make duplicates of a part without having to create the duplicate vectors. Let's say with my dice here, I decide that I need an entire sheet of the number 1 dice. The Array toolpath allows me to create a grid of them across the material. First, I make sure that the correct toolpaths are visible, then hit the Array toolpath button. In this panel, you can see the toolpaths listed. Here, you select how many rows and columns of the part you want, and choose the gap you would like between them. Name your array, and then calculate. Now you have a toolpath that gives you 9 parts from the vectors of 1. You can see here that the new array toolpath appears as a parent to the original vectors. If you change anything about the original toolpaths, it will automatically change the array. The one limitation of the array toolpath is that you can only add parts above and to the right of the original, so the part must be in the lower left corner for maximum duplication. Now we come to the tool that will likely be used more than any other tool in the software. The Preview tool allows you to see what the software will tell the machine to do before you commit to exporting the code. You can enter preview mode at any time by clicking this button. The software also takes you there automatically after calculating a toolpath. Once in the Preview Toolpaths panel, we have several options available. You can select the material for the preview. They have several options to pick from, though I'll be honest, I find them a little lacking in realism for the most part. I tend to use cherry for all my previews because I feel like it's the most natural wood-looking option. You can also set the material to a solid color. Just a note that nothing you do in the preview panel will have an effect on your final product. It is merely for visualization purposes, so you can find settings you like and use them no matter what project you're working on. You can adjust the color of the machined area here. I generally use material color, as that is more representative of what the carving will look like, but choosing one of these color options can really help you see carved portions better, or give you a visual if you plan to paint the carved areas. These two selections allow you to decide if you just want the final look or you want to see the tool perform the carving. I almost always leave these checked. Not only does it give me a good idea of how the toolpath will be carved, it can be pretty fun to watch the design come to life, just like watching the CNC work. So if you've selected Animate Preview, you will have a little speed bar here that lets you speed up or slow down the carving animation. I generally like it to be pretty fast, but sometimes it's helpful to slow it down and really see how the tool will be moving. You have options here to preview a selected toolpath, that's the one that is highlighted in blue, visible toolpaths, any with the check marks, or preview all toolpaths. The reset preview takes you back to the original uncarved material. You'll often need to reset when you've made changes to your toolpath since your last preview. Undo last will take off the last toolpath you previewed. So now that there are toolpaths previewed on our material, we may want to take a closer look at it. You can grab anywhere in the 3D view and move the picture around to get a good look at your potential finished product. Up in the right-hand corner of the 3D view, we have some controls for snapping the image to certain coordinates. The first is a nice angled view and lets you see some of the depth of the carving. I frequently use this one for pictures. Selecting the Z-axis option lets you view from overhead, and the X and Y axis let you view from the sides. Again, you can grab and move the model to see it from literally any angle. If you place your cursor over the carved portions, you can see the depth of the carving down here. Another option available is to double-click on any area in the preview to make that selection invisible, allowing you to see what parts will look like when they are cut out. You can also hold Control to move the model around. Once you have your model looking great, you have the option of saving a picture. Just click this button, choose where you want to save the picture, and what you want the name to be, and the software will create an image from the entire 3D view window. The next option in the Toolpath panel is the Toolpath Summary button. This will show you all of the currently visible toolpaths and give you time estimates for how long it should take to carve each one, as well as the total time for all the visible toolpaths together. This is just an estimation. I believe you can use these calculations here to try and get the times more accurate, but to be honest, I've never bothered. I find the times close enough, generally a little high, but good enough for me to plan how long a carving will take. There's an entire page in the manual dedicated to explaining these calculations if you'd like to delve more into it. The next button is used for tiling toolpaths. This is when you have a project that is bigger than your machinable area. You can break down the project into small sections on a grid and create the toolpaths that way. It's a rather complicated procedure I won't go into now, but comment down below if you'd like an in-depth video about the tiling process. Next, we come to the Create Job Sheet option. This allows you to make an HTML file that has a summary of your project, including information you may want to reference as you set up your machine. Here is a sample of the resulting job sheet. As an HTML document, it should open in any browser. First, you have a visualization of the job layout. This helps you reference where to put the material on the machine. The Material Setup section lets you know important information like material size and where the file is zeroed to on the material. Next, you have a toolpath summary along with the tool used and the estimated time. Finally, each toolpath will have its own block with all the details about that toolpath. This all may seem unnecessary at first, but we have found the job sheets to be very valuable. Firstly, I am always the one who does the designing in Vectric, but oftentimes my husband is the one who actually runs our machine. I print this out to make sure he always has the relevant information at his fingertips, and it saves us a lot of time answering questions back and forth like, where should I set the zero to? How thick is the material supposed to be? And so on. This also gives you a record of the toolpaths so you can run the file again at any time without having to go back and reference the software to check settings. Finally, we have the Save Toolpaths button, which will likely be the last thing you do in the software before moving the project to the machine. This is the tool that saves all your hard work to the coding needed for your particular machine. The default here is to save the selected toolpath, the one highlighted in blue down here. However, it's often faster to select to output all visible toolpaths to one file, like so. The list of toolpaths to be saved will then update with any toolpath that has a check mark in the box down below. Make sure you have the correct post-processor selected for your machine and click Save Toolpath. You can then choose where to save the file and what to name it. And there you have it. There are so many options available in Vectric VCarve. You are sure to find a solution to whatever you're trying to do. If you have any questions or comments, feel free to share down below. I do plan on doing in-depth toolpath videos for at least the more common types of toolpaths, so keep an eye out for those. As always, like and subscribe if you find value in our content, and until next time, have fun and stay safe in the shop.